Hello and welcome back. Today we are going to learn maximum subarray problem. Here is the problem statement. Let's go through the problem statement first. All right, over here. Okay, so given an integer array, find the contiguous subarray containing at least one number, which has the largest sum and returns its sum. Okay, so we're not returning elements, we're returning the sum of the largest subarray, sum of the numbers that has the largest sum. Okay, let's go through the particular example, then it'll be clear. So input, for example, we have minus 1, minus 1, 2, minus 3, minus 1, 7, and 1. And for this subarray, if we take, let's say, first two elements, okay, the sum is going to be 1, and then first three, sum is going to be actually minus 2, so it's decreasing, so that's not helping, right? So if you just take 2 and the element number 2 and element number 3, sum is going to be minus 1. That's that's still kind of negative. I mean, it can be negative, but it has to be maximum because we still see numbers that are positive on the far right. So we'll have to see that, right? So let's combine. If we combine this way, like minus 1 and 7, so that's also not going to be, well, that's 6. That's better actually. And how about this 3? That's going to be 7, right? How about if you combine with this one, now it's going to be decrease. We're doing minus 3, so that's not going to be maximum. So we need to find a logic for this in order to come up with the optimum answer for this one. So answer is 7 and 1. That's how it has the maximum sum, which is 8. So now let's do the main idea. What is the main idea of this algorithm? Is we get the we make it so the greedy algorithm. That's what we're going to implement. So what is the main idea? The main idea is to pick locally optimal move at each step, and then that will give us a globally optimal solution, right? So the like in a very high level, what we do is we iterate over the given array, and in each step we update three things. One, the current element, because it keeps changing in each loop, right, as we are walking through this particular, let's say, array here in this case. And then we also update current local maximum sum, okay, because that's going to change and we need to find the global one, right? And then we also swap and get the global up to this point, right? So we also have to update the global maximum sum seen so far because it keeps changing, right? Finally we get the maximum value. So that's the algorithm over here. So that's what we're going to implement, okay? And this is sample input and output for us to check, typically like a unit testing kind of thing, and the main idea behind the greedy algorithm. That's how we're going to implement, because in order to solve this problem, obviously there are different types of solution. In order to find the max subarray, we're going to pick this one because this is the shorter one actually, and let's go ahead and implement this. All right, I'm going to minimize that. Well, one more thing. What is the time complexity for this one? See our comparison. We're going to we'll see after the implementation. We're iterating through array just once, so it's going to be order of n, and we don't need any additional storage. It's a fixed storage, so it's going to be order of 1. The space complexity is going to be order of 1. It's a fixed storage, and time complexity, we're only iterating through the array only once, so it's going to be order of n, time complexity, and order of 1 space complexity for this particular greedy implementation for maximum subarray problem. All right, let's get started. Minimizing this one, and we're getting started. Okay, so let's say max subarray. Okay, max subarray greedy .java. That's our file name. We'll have to compile this eventually. All right, so let's start the class, because in Java I can compile without a class. I want to compile and see the results. Class max subarray greedy that's a class public static void main. Okay, string easy. Right. All right. We'll implement the calling stuff later. Let's implement the main logic here. We're going to make it public too, because ideally we could make it private, because there's one public method to call from outside, but since this looks more like a utility method, so we can make it a public. So anyway, we're not going to discuss about visibility, the access modifier in Java. That's not the goal of it, so we'll just forget that. For now, we'll just make it public so that it's available to invoke, and it doesn't matter whether I make it public or private for this problem here. So public static int is the one, because I'm going to return the sum, so it's just one value. I don't need an array or anything like that. Max. So this looks like a meaningful name. I can change this method name, it doesn't matter. And we're going to pass integer array, and let's name it easy nums. Okay, it's an easy name. And then we have first we need to know the length of it so that we can iterate through it. In Java, I need to specify the type. So length, I could have any stuff here. So length looks like a good name. So nums dot and then I need to initialize my current sum. See, we have three things actually: my current sum, and then my global sum, which is a max sum. That's what I'm going to eventually return, right? So my current sum initially, because I current sum, that's going to be, when I start, is going to be the first element. Okay, nums 0, I can initialize that to this number. And my max sum also, when I start, that's going to be the first number. Okay, now yeah, that's initialization portion is done. Now I need to iterate through the array. For so my loop control variable I is equal to 1, I is less than my length, I already calculated the length, and then plus plus I, or I can do I plus plus here, it doesn't really make a difference here. So now, see, remember, I need to update three things. One, this one, what was that? One is the current element, and then local maximum, and then the global maximum. Okay, so current element is going to be updated by this for loop automatically, so we don't have to worry about that. Now I need to update the current sum. So current sum is equal to max, and so we are going to get the max in each iteration. If the maximum is current number, then we're going to take that, because there is no advantage of taking the sum of current number and then the current sum, right? If current sum is already negative, and then it's only going to be less, because we're going to get the maximum, so it's not going to be helpful. So we have to get the maximum out of the current sum, or current sum plus nums. Okay, nums I. Okay, so whichever is bigger. If the sum is positive, then it's going to make a difference. Current number when added, it's going to be larger value, right? So we want that value. If the current sum is already negative, then probably it's going to only decrease the value. So we only take our current number, and from there we keep on going. Okay, and then we also need to update our max sum, because max sum is we need to take the max. We need to take the maximum of whatever is the maximum up to this point, and then current sum, because if the current sum is maximum, then that's going to be the new maximum, right? So it's easy. Okay, it's very easy, very easy implementation. All right, so let's now create integer array my nums. I need my numbers, right? So my numbers I'm going to get from our problem description. That's easy for us. In that way we can validate, because we are expecting that 8 thing which we already walked through. Let's minimize that, because both the screens have this darker background, so it's kind of a little bit easier now. Okay, anyway, so now I'm going to do one paste here, over here. Okay, over here. Ready? Am I in the right place? Are we? Okay, over here. All right, paste it. Let's do that. And okay, I have this one ready, and then I need to get my result, right? In my result, or I can say max of sub-array, right? And sub-array is equal to, it's a static method, so I can just call it. I don't need the instance of my class, and what I'm going to pass is my nums. Okay, that's straightforward. Now I'm going to print it. Dot out dot print system dot out dot println. Okay, and let's just print that number. That's it. We just need to see that one sum. Okay, semicolon. Okay, I think we did type the program that is required. Let's now go and compile it and then fix the errors that we get. Java C max sub array greedy.java. Let's see how many errors we get. Yes, sure. We get some errors, and we have line number 14 and 15 as expecting semicolon. Line number 14 and 15, 14 and 15 somewhere on toward the end. 14 and 15. Right. 14 is this one, 15 is this one. Since we are typing this Java and Python programs, one needs semicolon, another doesn't require it. So sometimes you forget it, but not a big deal as long as we can track and fix the errors quickly. That should not be a problem. So now I think we fixed that, but we need to validate it. Clearing the screen and compiling it. Who is any more errors? All right, all right. Cannot find symbol integer max sum is equal to num. Oh yeah, that's right actually, because our variable name is nums. It's not num. It is actually, you see, it is nums, right? Let's see if we used, okay, over here as well, nums, right? That's what we have. Okay, one more time. Okay, bracket, missing return. Oh, we need return in Java. Yeah, sure. Where do we close out? This one. Okay, over here, return. What are we going to return? Max. All right. Okay. That's became almost like a habit for me. Looks like because initially it's hard to change the habit of removing semicolon if you're moving from Java to some other languages, and once we move to some other languages that don't require semicolon, now that forms more like muscle memory and you just forget it. Okay, compiling. This time there is no error. Max of array greedy, right? So we run it. Max of array. We're expecting number 8. That's it. We are done, and we already did the complexity analysis for this. So we are done with the Java implementation of max of array problem using greedy algorithm. Next, immediately we're going to write a Python solution, and I will see you on the Python video.